Okay, so today we're going to be reviewing this. Marley is going to be teaching today at 4 p.m. on quadratics. Um, and so we already know that the SAT has two sections, 35 minutes, 22 questions in each section. You can use the Desmos calculator. Today's algebra is honestly almost a third of the exam. So it's a good idea you decided to join today. So I'm gonna fly by some of these since they're mostly review, and then we can save time for practice questions at the end. But just so everybody knows, we can do minus 4x, rewrite it as y equals negative 4x minus 8. Then we get y equals 3x minus 1, y equals negative 4x minus 8. We equate them to each other or we substitute. So we get 3x minus 1 equals 4x minus 8 minus 3x, and look, I already dropped the negative, moving it over. And then we do plus 8, we get 7 equals negative 7x. So x equals negative 1. Then we plug it back in. Y equals 3 times negative 1 minus 1. Y equals negative 3 minus 1. Y equals negative 4. Just since we're early on, I'm going to do the same thing in the second equation. So we get 4 times negative 1 plus y equals negative 8. Negative 4 plus y equals negative 8. Y equals negative 4. So it checks. It does it for both. The answer is yeah, negative 1 comma negative 4. Okay. Now we have this one. Solving by elimination. You know, you might want to rearrange the formula to substitute back in. But if you look at this, and since we want to spend less than 90 seconds or so per question, you can see that the y is plus minus. It could cancel each other out. So we do plus 3x plus 2x equals 5x. Let's write that neater. Okay, same thing. Negative y plus y is 0y. 7 plus 8 is 15. So now we have one variable. The goal in both the last substitution example and this elimination example is it's really, you need two equations with two variables, and you want to ideally end up with one. So then we have 5x equals 15, divide by 5. Technically, this gets divided by 5 too. And we get x equals 3. And really important, we want to read the full question. It's only asking for x. You don't even need to solve for y. All right, let's move on to this one. I'm just gonna, it's a little bit more confusing because you can't easily do 2 and 3 unless you make it 6y. And even this x and 7x, you could only make the first equation multiplied by 7. Both methods would work totally okay. Is there anybody that needs to be admitted to the room? Let me admit them all. Sorry. Okay, sorry about that. What I like to do is multiply this whole thing by 7. So we get 7x minus 14y equals negative 14. And then we have 7x, the second equation, minus 3y equals 19. But it still gets a little tricky because if you add it straight down, you still have two variables. So you have to subtract the second equation from the first equation. So we're going to do minus 7x plus 3y minus 19. And then if we add it down, we get 0x minus 11y equals negative 33. Y equals 3. And we're going to plug it back in, and we get x minus 2 times 3 equals negative 2. X minus 6 equals negative 2. x equals -2 plus 6, which is 4. So the answer is 4, 3. Sorry, we have more students joining. Just admit them. All right. Now we have 41 people going to a concert in either cars that can hold 7 people or cars that can hold 5. I like to make M equals 7 people for like a minivan is what I'm thinking in my head. Okay. The pen is having fun with me today. M7. And then S, like a sedan or a car, holds 5. And the equations for M and S are M plus S equals, there's 7 vehicles total, 7. And for 41 people, we have 7M plus 5S equals 41. Since only 7 human beings can fit in a minivan and 5 human beings can fit in a sedan or the car that holds 5, and then we have 41 people. You could use the same substitution and elimination to solve, but since we really want to get to 90 seconds or less per problem, what I really like to do is do minivan, and since it's asking how many vehicles can hold 7 people, these are number of vehicles, so I'm going to do a number of people. 7, 14, 21, 28. And this is because if we have one minivan, that means there's 7 people in who are going in the minivans. If we have 2 minivans, we have 14 people going in the minivans, 3, and the same for 28. Then what I do is I take S and I check for S. And since N 41 minus 41 minus 41 minus 41 minus 41 minus 7 is 34. That means 34 people are going in sedans. And since the rest can hold 5 people each, whatever number comes out in this S column has to be divisible by 5. And without even doing the math, we just need the last integer, the singles, forgot what that's called, but the last single digit to be 0 or 5. So 41 minus 14 is 27. 41 minus 21 is 20. 41 minus 28 is 13. And there's only one that ends in 0 and 5. And so even without doing these equations, you can, if you're not comfortable with algebra, you can just on your piece of paper in under a minute solve and kind of plug and chug and check each one. Alternatively, we're going to cover this soon. We're going to use the Desmos calculator a lot coming up in this session. It's really easy for me to do it since we have the digital lesson this week. You could plug these equations in and find where they intersect, and that gives you the value of M and S because it's basically X comma Y. And then for M, you would just see what is the value of X. But that's if you're very comfortable with Desmos. So something that the SAT will for sure test and loves to test is kind of systems of equations in terms of parallel, one intersection, or the same line. And so if we have kind of in the terms of y equals mx plus b, m equals slope, and b equals y intercept, if m and b are the same for 2 lines, that means that there are infinite number of solutions. Okay, because it means they're the exact same line. If m is the same, so if the slope is the same, but b is different on the 2 linear equations, then that means that there is no solution because they can never intersect at any time, which also means that for all values, the lines are parallel, like this one. Everything else, if the m is different, and the B can be same or different, it doesn't matter, then we have one solution, which means lines intersect, which is honestly most of the time. But the SAT is going to test if you understand this. And the simplest way to break it down is thinking y equals mx plus b, and you're thinking about the slope, and you're thinking about the y-intercept. That's it. For this one, I'm actually going to go ahead and use Desmos. So let me just switch my screen share. Let me fix my screen. Okay, this is horrible to see. And I know you can't see it, but let me just pull it out a little bit. So one of two equations in a linear system is 2x plus 6y equals 10. This is super gross to look at because it's not in y equals mx plus b form. So if you're really comfortable, you can basically convert it to y equals mx plus b. So the system has no solution. And for no solution, that means that the lines have to be parallel. So the m has to be the same and the b has to be different. So you can sit there and solve that, and then you can convert all of the answer choices equals into y equals mx plus b form and look for the one where m is the same and b is different. Or we can spend less than a minute if we look at the question and we understand that. Okay, and what I'm going to do is graph it. Sorry, it's so hard to see. Okay, so the first one is this. Oh, 2x plus 6y equals 10. Whatever, that's the first one. The second one is x plus 3y equals 5. And if you're really good at mental math, you probably already could see that they are the same line. So this doesn't mean they're parallel. This means that there are infinite solutions. So A is out. Then we go to B. X plus 3y equals negative 20. And it's kind of nice. It's answer choice B. But we can see that it is parallel. And they have different y-intercepts. And it looks like the same slope. Since we're graphing and we have a little bit of extra time, we can check C and D. This is 6x minus 2y equals 0. And this is for D, it's 6x plus 2y equals, what was it, 10. Okay, so answer choice C intercepts this first line here. And you can see the colors, you can see which one we're looking at here. And then answer choice D, which is in red, also intersects the line at one point. So the only answer choice is B, and it's so much faster to graph on Desmos instead of sitting there and converting them all to y equals mx plus b. Okay. Same thing for this equation. We have negative x plus 3 equals y, and we have negative 6x plus 18 equals 6y. And the question is, which of the following answer choices accurately describes all solutions to the system of equations shown? And so if we just look over to the right, we see some values for x and y. We also see that it's an option choice is infinite solutions and no solutions. So when you see that, you should think, oh, SAT is trying to test, do I know if this is parallel, infinite solutions, or just one solution? And so what we're going to do is if I look at it, I can see that the second equation is 6 times the first equation, but sometimes we can't see that. So we can go to Desmos. And again, we can do it in under a minute. Sometimes Desmos can help us score a little bit better. Okay, so we have negative x plus 3 equals y for the first equation. And negative 6x plus 18 equals 6y. Sometimes you might think, oh my God, where did the line go? Did it graph it? But you can see the green one is overlaid over the blue one. And if we flip it, then the blue one is overlaid over the green one. And so you would know that the answer choice is C. There are infinite solutions to the system. Does anybody have any questions before we move into the practice problems, where I'll give you guys a few moments to answer each one, put your answer choice in the chat box, and then we can go over it. Let's start with this practice problem. If you can take maybe 2 minutes to work on this and just put your answer for in the chat box. I think we had 3 entries, so if we can get 2 more, then I can work on the explanation. And if you've just joined the class, then if you can put your first and last name in the chat. So that's why how we're taking attendance. Okay, I'll show it. Okay, so I see one question. I'll solve it and then I'll answer your question, Connie. Okay, so it's this equation. We have 8x minus y equals 12. And then we have 2x minus 6y equals 3. You know, we can solve it out, or we can use our handy dandy Desmos. And so we have 8x minus y equals 12 and 2x minus 6y equals 3. And you know, it looks kind of weird. We zoom in and they intersect at 1.5 comma 0. So the question is not asking x comma y, it's asking for x plus y. X is 1.5 and y is 0. So if you add them up, it's 1.5. I'm also just going to show it algebraically, just because I believe there's many, many ways to do math. I actually don't care how you do it, as long as you get it correct. Okay. So we have 8x minus y equals 12. And so when you look at it, you know, you can substitute or you can eliminate. My preference in this case is elimination. And so I can either multiply the second equation by 4, so we can cancel out the 8x, or you can multiply the first equation by 6, so you get 6y. 4 is a smaller number, so let's just do 4. So we have 8x minus y equals 12, and then times 4, we get 8x minus 24y equals 12. Make sure you multiply it across the board. If you want to be even smarter, we can do multiply it by negative 4. So we get negative 8x plus 24y equals negative 12. Just so that it's easy to see. If we add down, 8x minus 8x is 0x. Negative y plus 24y is 23y. And 12 minus 12 is 0. So if we divide by 23, y equals 0. And we're going to plug it back in. Let's plug it into the first equation. 8x minus 0 equals 12. 8x equals 12. X equals 12 over 8, or x equals 3 over 2. And since it's x plus y, I'll write that cleaner. X plus y equals 3 over 2 plus 0. That's the solution. Anybody have any questions on this one? Let me just look at that chat box for Connie's question. So Connie asked, how do you solve for problems where they ask us to find an unknown variable in one of the equations to make sure the system of equations has no solution? Are you talking about Sorry, let me just make sure. Connie, are you talking about this one or this one? See if Connie answers. Yeah, Connie, you can go ahead and give an example. 2x minus, let's try this out. So I'm just going to do it right here. So it's on the 2x minus 5y equals 8. Okay, and you have 4x plus ky equals 17. And so part of the question you're saying is that they tell you that the system has no solutions. So no solutions. Oh my God. No solutions means it's parallel. So the first thing I'm going to do is change into y equals mx plus b form. This is a great question. I think this is a really nice one. So this first one, I'm going to do negative, pen is being funny, negative 5y equals negative 2x plus 8 divided by negative 5. Okay, I'm so sorry. My pen is not working. Okay, now it's working. Sorry about that. So then we get y equals negative is 2 over 5x minus 8 over 5. That 2 over 5x is all we need. I'm sorry, it's now like a brush stroke. And so when we rearrange this equation, we're going to do ky equals negative 4x plus 17. All you need to worry about is you can ignore the negative 8 over 5 and the 17. And basically it's 2 over 5x. We're going to divide by k. So I want this to equal that. So 2 over 5x equals negative 4x over k. Then you get rid of the x. So we're going to get rid of this x, get rid of this x. Let's do a little eraser. Okay, they get rid of each other. And you just cross multiply. And then you get k. So then we get k equals negative 4 times 5, 2k. So k equals negative 4 divided by 2 is negative 2 times 5 is negative 10. Connie, does that help? I'm so sorry. My pen was having a field day. It's going to be a bloodbath in the recording. Okay, so this was the last one we had done. Let's go ahead and try this one out. And I'll give you guys another 2 minutes to work on this one. One more response, and then I can work on the solution for you. Okay, great. I think we got 3. I'm just gonna look at them. All right, everyone answered A. That is correct. So for the linear function h of 0 equals 41, you can quickly write 0 comma 41. And the second one is 1 comma 40. These are both equations on the line. And since we're looking to solve this in under 90 seconds, in my opinion, the best thing to do is to take the x value, 0, and see if 41 comes out in each option. So we can do x comma y. And so if we plug in, and honestly, we should do it for both equations, or both, not equations, both solutions, 0, 41, and 1, 40. So in the first one, when we punch in 0, negative 0 plus 41 is 41. And if we go to the second one, if we punch in 0, we get out 0. In the third option, or answer choice C, if we punch in 0, we also get 0. And in D, when we put in 0, we get negative 41, which is also wrong. So already off of this first plug and chug, you could pick option choice A. Personally, I prefer if you just check if the second solution works. So if we plug in 1, negative 1 plus 41 is 40. If we plug in 1, we get negative 1. If we plug in 1, we get negative 41. And if we plug in 1, we get negative 41. The other thing, if you're really good at writing equations, we can see that the y-intercept in y equals mx plus b has to be 41 since the y-intercept is 41. So also off of that alone, you can also pick answer choice A. And if you're really good, what you can do is you can also punch it into Desmos and that's what would come out. You can check those things. But personally, I would just plug and chug. And if you're really fast with y equals mx plus b, you could see that the y-intercept is 41 and you can just pick whatever has the y-intercept as 41. The problem is answer choice D does too. So when you plug this equation in, or the second solution in, it doesn't work. Anybody have questions on this? I know I've been using weird terminology, but this should be one you're able to grab. All right, let's go to this one. Let's go ahead and take maybe 3 or 4 minutes to work on this problem, and then I can work on the solution for it with you guys. The theme of these classes and lectures is they get incrementally a little bit harder. All right, I'm going to go ahead and work through the solution. So we have a small airplane that can carry passengers, luggage, and mail as long as the total weight is less than 1,700 pounds. So we can write that as people plus luggage plus mail has to be less than 1,700 pounds. And so on Tuesday, doesn't matter, any day, this specific day, the load of mail weighs 4,900 pounds. So we can plug in 4,900 for M. And it gives us one more detail, which is if the average combined weight of each passenger and their luggage is 170, what's the greatest possible number of passengers that can travel on the plane? So now it gets a little funky. What I like to do instead is do P plus L. Let's make it a combined value. It's like an average. So let's just call it A. And so A, because every person has luggage, it's almost like a combined number. A equals 170 pounds. Sorry, it's A, that's not it. I'm just gonna write that P and L equals A. So now we know that for every human and their luggage, the combined weight is 170. So we're gonna do 170 times A to substitute for P plus L. And for M, we have 490 pounds is less than 1,700. Now we have 170A is less than 1,700 minus 490. If that was 500, it'd be 1,200. So I think it's 1,210. Let me just check my math. It is 1,210. When we subtract 490, do a little cutely written. Now we have to divide by 170 to get the value of A. And A has to be less than 120, 12, 1,210 divided by 170, which is 7.117. And since it needs to be less than, the only integer that's less than that in the answer choices is A. Does anybody have questions on this? Because I think it involves a couple steps of like creativity. Let me see if anyone's typing in the chat. No questions? We all get it? Okay. Let's try this one. I'm gonna give you all maybe 2 minutes to work on this one. And I'll give you a little hint. Desmos could be super helpful here. Okay, let's go ahead and solve this. So I really like Desmos for this because it's an inequality and there's like a shaded region. So for me, it's really easy just to see if I graph it. So we have y is less than equal to negative 3x minus 4. And in the second equation, we have y is less than equal to 3x minus 8. Okay, and so oh, sorry, 3x plus 8. And so from here, it's a little bit weird to see, but we're looking for where red and blue, when they overlap, or they don't overlap, to have no solutions. And so we see red and blue is in a little bit in quadrant 2, a lot in quadrant 3. We see it increases in quadrant 4, but it never actually is in quadrant 1. It's just the y is less than equal to 3x plus 8 that has solutions in quadrant 1, but the first equation, y is less than equal to negative 3x minus 4, is not in that. Anyone have questions? Okay, let's move to this one. Let's take about 2 minutes to work on this. Okay. The question is asking for a high school dinner function for teachers and students. The math department brought 6 cases of juice and 1 case of bottled water for a total of $135. Sometimes word problems just give us the equations really nicely. So we have 6 juice plus 1 water equals 135. Then the science department brought 4 cases of juice and 2 cases of bottled water for a total of $110. 4J plus 2W equals 110. Question asks, how many cases of juice, how much did a case of juice cost? Okay. I basically, when I look at this, when it asks you how much did juice cost, you want to, when you do substitution or elimination, it would be a waste of time to solve for W first when you can just solve for J first and just have your answer. And also the equations are kind of set up that way. So we have 6J plus 1W equals 135. 4J plus 2W is 110. It would be really nice to just multiply the first equation by 2. And we get 12J plus 2w equals 270. 135 times 2 is 270. Then we have 4j plus 2w equals 110. Same equation. Now what we're going to do is we're going to subtract the second equation from the first equation. So what we can do is take out the signs actually and just do minus 4j minus 2w minus 110. And so we have 8j plus 0w equals 270 minus 110 is 160. And it's so elegant. We can divide by 8 and we get j equals $20. Answer choice C. Does anybody have questions on this problem? Trying to see the chat. No one. Okay, cool. Let's go to the next question. And let's do this one. Let's take maybe 2 minutes to work on this. All right. What is the equation of the line that passes through the point 0, 5 and is parallel to the graph of y equals 7x plus 4? If y equals 7x plus 4 and we want to draw a line that's parallel, we want in the equation y equals mx plus b, m to be the same and b to be different for parallel. Okay? Very nicely though, 0, 5 is the y-intercept and 7 is m. So it's y equals 7x plus 5. And that's it. I think if you wanted to plug and chug, you could. The problem is, like for answer choice A and B, well, actually, yeah, the only one it works for is B. If you wanted to plug and chug 0, 5. I'm just going to test that out to make sure I'm correct. So if we plug in 0 here, we get 0. If we plug in 0 here for x, 7 times 0 plus 5 is 5 for y. Let's do x is 0, 0. If we plug in 0 here, we get 0. If we plug in 0 here, we get 7. So you actually don't even need to do y equals mx plus b. You can just plug in and see if you get 0, 5 as a solution for any of these equations. In the case it works for 2 of them, if you plug and chug, you should do them all. In the case it works for 2 of them, then you would need to probably come back and look at the question one more time. Okay. So yeah, it's B. Okay, this is the last one. Sorry, let me get rid of the solution. I like to practice before we do these. Let's take maybe 2 minutes to work on this and then I'll do the solution. This one's a little bit more funky because of all the fractions. All right. I'm gonna go ahead and solve it. So we have 3 over 2y. And I'm just going to rearrange. Okay, let's just do minus 1 over 4x equals 2 over 3 minus 3 over 2y. If we rearrange it, we get plus 3 over 2y plus 3 over 2y. Let's do plus 1 over 4x plus 1 over 4x. Connie, this is just like the one you had asked about earlier, but a little bit more funky. So then we have 3 over 2y plus 3 over 2y is 6 over 2y, which is also 3y. So we have 3y equals 1 over 4x plus 2 over 3. That's there. Just make sure I didn't drop any signs or anything. Then the second equation is 1 over 2x plus 3 over 2 equals py plus 9 over 2. I'm just going to go ahead and let me rearrange that. I'm going to just erase this so we have a little more room. And I can go like this, move it up all the way. Okay. 1 over 2x plus 3 over 2 equals py plus 9 over 2. We have negative py equals negative 1 over 2x. 3 over 2 minus 6 over 2, or minus 3 over 2 is 6 over 2, which is 3, so plus 3. I didn't drop everything, that looks good. Then we get y equals 1 over 2px plus 3. Okay. And if the system has no solution, that means if the lines are parallel, so the x-intercepts, the y-intercepts are different. Sorry, that's not it. They're 2 over 3 and 3, so we know that. All we need is to make 1 over 4x equal 1 over 2px. And sorry, the p is actually on the lowercase x. So then we get rid of the x's, and we get, I'm going to do it over here, 1 over 4 equals 1 over 2p. So 2p equals 4, p equals 2. If I didn't drop any signs or anything, that's correct. And we're right at time. Why is it, so Afsal is asking, why is it still positive 3 and not negative 3 over p? Where's that? Okay, sorry. So just rearranging the equation. It's 1/2 x plus 3 over 2 equals py plus 9 over 2. It could, oh, minus. You can rearrange it to be 1 over 2x minus 3 equals py right here, if you go from this to there, which is what we have. Yeah. Okay. Lily is in the room now.
Yeah, hi everyone. Okay, well, I hope you guys had a good math class and you can see Monsoon tomorrow, right? And at 11 o'clock again to be doing geometry tomorrow morning, right?
Yes.
Great.
Do I need to make you host or you host? Your host. I'm gonna hop
All
off.
right, fantastic. All right, bye, Monsoon.